I have a video here to help everyone, including the distance learners, that would be eligible for a retake on this test. There are a lot of issues here. The biggest one seems to be that people are not listening to the notes. So you have to listen to the notes in order to catch everything. And I realize that some of you probably thought it's all review. I can just watch the notes or write down the completed lesson notes copy. It's not going to work. Pre-calculus is about precision. It's about elegance. Again, that's the word in math that says we've made everything as perfect as we possibly can. So the steps for retaking the test, first thing you're going to do is you're going to watch this video all the way through, and you're going to take note of the important reminders, so you'll write them down as you hear me talk about them. I'm going to talk about common things that people missed on the test, and then some things that you absolutely have to clean up so that you can do well and be successful at the pre-calculus level. As you watch the video, there will be code words, and you need to write those words down. I'm trying to make sure that you're actually listening to what's being said. So I will say code word, and I will give you a code word, and you will write it down. I'm not writing it down. And if you don't have those code words by the time you get done, you're not going to retake, because that's one of the first things that I'm going to ask you is, okay, give me the code words. Then, like it says, you don't share them with others or you're going to lose your retake opportunity. Somebody will tell me, or I will hear from somebody, that you shared that information, and when that happens, your retake is done. So, step 3. Once we've gone over this video, you're going to go back in your notes and you're going to highlight the problems that are similar to the test problems. You might want to have your notes with you right now, and you can kind of pause the video as you go through so that you realize, oh my gosh, this was just like this problem that we did in the notes. Everything that we have here is right out of the notes that was in the test. And you're going to redo the review assignment. You're going to go back and you're going to do this with precision this time, with your math being elegant and making sure that you've done all of that correctly. You need to check your answers, and again, all of that is online, but you have to make sure that that is completed, and it's completed to the level that's expected at pre-calculus. When that's done, when you've done all those things, you're going to contact me before October 1st with number 1 through 4 above completed. I'm going to check and make sure that they're done. I'm going to ask to see all of those things. And then the retake deadline is October 2nd. We will have already taken another test by then, and we can't wait any longer than that. So the retake process is a lot of work, and you really have to start focusing on listening to the videos. On your note packet, you have a little strip margin that you could write things on if things come up, and I've mentioned them in class or during the lesson. And you need to take note of them, because those are the things that you're missing. Now, distance learners are going to recognize this as the test that they took. So what I'm going to do is go through this with you, and then I'm going to go ahead and, as I go through it, talk to you about some of the things that I saw that people are doing. And they might be just 1 or 2 people that did it, but I have to make sure those habits are stopped. So number 1 says describe and graph the interval of real numbers. So there's 2 pieces to this. The first one is to describe it, and I have to say what this inequality is saying in words. So X is going to stand for all real numbers, and you read this from the inside out, so it's all real numbers that are greater than -2, and, because this is an and sandwich here, and less than or equal to 3. So there's the description right there. All real numbers that are greater than -2 and less than or equal to 3. And then we go ahead and do the graphing by showing that -2 is not included with parentheses, but that 3 is with square brackets, and you absolutely shade in between. So all of those things had to be there in order for you to receive all of the credit for that problem. Now, your first code word is must. M-U-S-T. Must. Number 2, use set builder notation to describe the interval of real numbers. So what I have to do is remember that I have to use the brackets. You don't have to be perfect at making the brackets, but those brackets are special in math. They tell mathematicians that you are talking about a number set. And then you have to decide, are you going to use X, or are you going to use N? What are you going to use? I'm going to use X. And what I have to do is translate this in the interval notation into inequalities when I do set builder notation. So what that's telling me is X needs to be sandwiched between -6 and 1. And I can see that there's no equals bars because there are no square brackets anywhere on this. So that's how we use set builder notation to describe the interval of real numbers. Make sure that these two variables are a perfect match, because what this says is X is defined as. That's what that line means. X is defined as. And then we have X is greater than -6 and less than 1. Then, number 3, use interval notation to describe the interval of real numbers. This is why interval notation is so important. Basically, you look up here and see, well, we don't include the 3, but we do include the 7 because it has the square brackets. And that's all you have to do, is you have to match it up with what you have here. So that's describing that interval, and that is interval notation. Number 4 says we're going to use words to describe the interval of real numbers. So this again means saying all real numbers. Read it from the inside out. So all real numbers greater than or equal to -2 and less than 8. So putting it into words, putting it into a sentence. Now, we're not so picky as they might be at college. In college, instead of writing -2 in mathematics with numerical answers, they might make you actually use -2, completely spelling it out. The same thing with the 8. But we're saying, hey, the numerals are okay. It's math, for goodness sake, but make sure you get the rest of the words in there, and then you're fine. A says convert to set builder notation. So again, I realize I have to have my brackets. I have to try them. They don't have to be perfect. And then I want to think about what this is saying. This is saying that I'm going to include the -8, and then I'm going to the right forever. And I have to pick a variable, so I'm going to pick X. And I want to include -8, and I want to go to the right forever. Well, to the right forever is going to be positive infinity, so X is greater than or equal to -8. Again, I'm picking X. X is defined as, that's what that line says, X is greater than or equal to -8. And another set of brackets. Notice there's only one line. That line means is defined as. Now, we have to state whether or not this is bounded, unbounded. And so what we're looking for bounded or unbounded is, did it have infinity in it? And it did. So that means this is going to be unbounded. And then, how we tell whether or not it's open or closed is we look for the square brackets. If we have square brackets with infinity, then that's going to be closed. So that was basically the first page of the distance learners test right there. Time for another code word. The code word is listen. L-I-S-T-E-N. Listen. Now, number 6 says use words to describe the interval of real numbers. And I can see from the square bracket and the arrow up there that we are talking about the numbers from 3 on to infinity, but now I need it in words. So that's going to be the real numbers greater than or equal to 3 that make that happen. Number 7 says use interval notation to describe the set of numbers. Every item in Albert's variety store costs less than $3.12. So that means we have to think about what happens in the real world. And in the real world, they aren't going to pay you to take things out of the store. So zero, they do occasionally give things away for free. Not very often, but they do give things away for free. And sometimes it's like the samples, that you get at the store. And everything is less than 312, so that means we can't include the 312, which means we would have to put parentheses on there. So that was using the interval notation to describe the set of real numbers. Number 8 is just, do you know the vocabulary? And the base is the number that's being raised to the power. So that's -10. You don't do anything more with that. Identify the base, do not evaluate. Now when we get down to number 9, this brings up something that a couple of people did. They started doing things like changing a B, a lowercase b, to a capital B. That is not allowed in math. Lowercase letters are for basic parts of a formula, whereas capital letters usually indicate that there was something else, some other math that you had to do to, in this case, back in geometry, a capital B like that could stand for the area of the base of a pyramid. But a lowercase b is just a number. There's something that we're going to put in for that lowercase b. So for number 9, you do not get to change b's and make them capital B's. You can't do that. You have to stick with what you have. So this says simplify the expression, assume that the variables in the denominator are non-zero. And there's many different ways to go after this one. What I will usually do is do my reducing and cross-reducing, canceling things out, but then put it all in one fraction so I can take a look at all the variables I have. So 3 times 2 would give me 6, and then I multiply top times top and bottom times bottom, a to the 6, and when you multiply similar bases, you add the exponents, so that would be a b to the 7th. Now on the bottom, I only have a 1 for my coefficient, but I have a to the 4th and b to the 9th. Now that it's one fraction, I can remember that when you divide similar bases, you subtract the exponents. So this would be a 6, and then 6 minus 4 would be a squared, and 7 minus 9 would be a -2. But rather than write it, I will right now just so that everybody can see it. Usually I'll just drop it down to the bottom to make it positive. So this would be 6a squared over b squared. And like it says, we're assuming that the variables in the denominator are not 0 because we can't divide by 0. So it's telling us basically don't worry about the domain. That part has already been taken care of for you. Number 10 is another one where there are a lot of different ways to work through this. But what usually ends up happening if somebody makes a mistake is that it's because of negatives. So one of the first things you can do to get rid of the negatives is take care of those two. Because we have it to the -4th power and the -5th power, we could take the things from the top and put them on the bottom, and the things from the bottom and put them on the top. So this will become y to the 4th, x to the -5th, to the 5th power when I move it up on the top. And then this will be x to the -3rd, y to the 4th, to the 4th power on the bottom. The fewer negatives that you have, the better. Now we can go ahead and distribute those powers, and while I'm at it, I'm going to put these in alphabetical order. That's another point that I needed to make with everybody, and that is we always put the variables in alphabetical order if they have the same powers. And a lot of times when they don't have the same powers, we also put those in alphabetical order. So what we want to do here is think x and y. So x to the -5th raised to the 5th will be x to the -25th. And 4 times 5 will be y to the 20th. On the bottom, x to the -12th, y to the 16th. Because when you raise a power to a power, an exponent to a power, you multiply. And now I can remember, all right, I need to subtract again. This will be a base of x, -25 minus a -12 is going to be -25 plus 12, which is -13. And then 20 minus 16 for the y's is 4. And then I realize I'm not done because when you simplify, you can't have any negatives. So I take that x to the -13th and move it down to the denominator so that it becomes positive. So y to the 4th over x to the 13th. Again, lots of different ways to do this. You could come back and say, you know what, Cedarholm, I'm going to distribute that negative first. So x to the 12th, y to the negative 16th over y to the negative 20th, x to the 25th. Hey, if you do the math right, you'll get to the exact same answer that we did. But obviously there were people that got that wrong, or I wouldn't be talking about it right now. Number 11, write it in scientific notation. In math, when we write scientific notation, we do not use a dot, ever. And we don't ever write it like that. That is computer and calculator language. We are doing math. We are not using the calculator to do it, and we need to show that. So what we have to figure out is how many decimal places are we talking about here? And there's 3, 6. So it's 3.10226 times 10 to the 6. Because again, what you have for your integer portion out in the front needs to be a number between 0 and 9. So we come over here and we see, well, that'll be a 3. So 3.10226 times 10 to the 6th. Then we have this one, which says, hey, this is in scientific notation, move it back. So what we would have to do, because this is to the negative 6th power, is make this a smaller decimal. So we're going to have to move the decimal place over 6 places, 1, 2, 3, 4, 5, 6. And that means I'm going to need 5 placeholder zeros after my decimal. 9599. And when you read the test before you took it, or we talked about it in class, no rounding. We want everything perfect, so we want all these decimals. There's no rounding allowed at this point. Time for another code word. The code word is to, T-O. 13 says evaluate the expression. And this has a 5th root. Now, it might take you a little while to figure out, what all those 5th roots are. It's been a while since you've had to do anything like that. But eventually, you would find that 3 to the 5th is 243. And 243 goes into 1,701 7 times. And then I would have a 5th root of x to the 5th, but I'd have 1 left over to get me x to the 6th. I would have a 5th root of y to the 5th, a 5th root of y to the 5th, but I have 2 of those left over at the end. Now we go back and see what everything is. So 5th root of 243, that's going to be 3. 5th root of 7 is obnoxious, so we have to leave that there. 5th root of x to the 5th is x to the 1st. 5th root of x to the 1st is obnoxious. We leave it underneath that ugly radical symbol. And then we'd have a y times y, and then we would have, in fact, so that we don't accidentally think there's any decimals or anything in here, 5th root of y squared. Now this problem, some of you, I didn't take a lot of points off, but I did take 1/4 of a point off because you didn't have your index in the V. That's really important, and it was something that I talked about on the notes, which tells me you're not listening to the notes. If you are doing this, the only reason that you see that in the book is because they're using a font that doesn't allow them to put the 5 in the V. And that's the way a book writes. That's not the way human beings write. So you need to make your V deep enough, big enough, so that you can put your index in there. Because that's the acceptable way to write these. So now, let me pull the good stuff together. I have a 3 and an x, and I have a y squared. And then under the ugly radical symbol, I have a 7 and an x and a y squared. And then I ask myself if I need to bother with absolute value bars. And this is an odd index, so no, don't have to worry about it. So like I said, I think the most I took off for not having the number in the V total on any test, I know it was a half a point, which basically would take your test from 100% down to a 99. So that's not the reason anybody suffered on this test at all. It's something you need to fix, though, and we need to fix it now. So make sure that your index is in the V. Number 14. With this one, we want to rationalize the denominator, and you have to notice that very special 81 in the denominator. Otherwise, you're going to use huge numbers for this one. So 81 is really 3 to the 4th. And that's one that we used quite a bit in Algebra 2. So if you recognize that, that makes this problem much easier. We have the 5th root of x to the 3rd over the 5th root of 3 to the 4th y squared. And we realize that we have to make the index match our power, our exponents. So I'm going to need one more of those 3's to make that 3 to the 5th, and I'm going to need 3 more of those y's. But whatever we do to the bottom of a fraction, we have to do to the top. So we will multiply by that in the numerator as well. Now, because I ran out of space, I'm going to go over here. And in my numerator, I have 5, the 5th root of 3x to the 3rd, y to the 3rd. And in my denominator, I now have the 5th root of 3 to the 5th, y to the 5th, which is perfect because that's going to be 3y. Because our radical and our powers are perfect matches. They are inverses of each other. And then there's nothing else I can do about my radical in the numerator. So unless we need absolute value bars, that is done. And we don't need absolute value bars because this was a 5th root. It was an odd root. So again, the only time you're going to see that root not in the V is because it's been typed out. And we are not typing these out. We are writing them out. So you need to have that in the V. Looking at number 15, with this one, what we have to do is figure out that, okay, I've got my rational powers here, and I need to, well, first of all, take care of the 32 and 4. Might as well take care of that right away and do a little bit of reducing there. But in order to multiply what I need to, numerator times numerator and denominator times denominator, I have to add, because when you multiply similar bases, you add the exponents. So I am going to need a common denominator for those. So I'm going to change that 3 halves, and I'm looking at all the other numbers, and I see that I have denominators of 2 and 3. I'm going to change that into 6. So my 3 halves is going to need a 3 on the top and the bottom. And same thing on my denominator. I'm going to have to make that into 6, and now I'm going to skip a step here and just go directly to that by multiplying the top and the bottom by 2. And then we'd have x to the, multiply the numerator and denominator by 2, and 3 down here. All right, so we've got an 8. And then we have 9, 6, and 2, 6 for x to the 11, 6. And then in my denominator, 4, 6, and 3, 6 would be 7, 6. And then I realized, well, I have to subtract. And that's because when we're dividing similar bases, we subtract. And that would be 4, 6, which of course I'm not going to put down as an answer because that's not reduced. So 8x to the 2/3. Now, a big thing with this problem, some of you tried to go with radicals. You can't do that. If a problem is given to us in rational exponents, our answer needs to be given in rational exponents. And it actually makes this problem much more difficult if you do it that way. So if a problem comes with rational exponents, then our answer needs to be in rational exponents. It was a problem to force you to show that you understand the properties of those rational exponents. Number 16, this is another one that might have taken you a little while to find those perfect cubed roots, but an easy way around that it's kind of an educated cheat, is to say to yourself, I'm going to work on the smaller one first. So let's see. 2 times 2 times 2, that's 8. Ooh, that goes into 56. So it'll be the cubed root of 8 times the cubed root of 7. And then I realized, well, the cubed root of 7, that's as simplified as that gets. So if I'm going to be able to do this problem, then, let me move my 9 here, is it has to be a cubed root of 7. That's the only way I'm going to be able to add these, is if they're like radicals. So then you take 448 and you divide it by 7, and you find out that you get 64. And it just takes you a second to realize, well, that's 4 times 4 times 4. Oh yeah, that's a perfect cube. So we have 9 times 4, cubed roots of 7, plus 2 cubed roots of 7. Because when things are right next to each other in algebra, that means you're multiplying. So 36 cubed roots of 7 plus 2 cubed roots of 7, which is 38 cubed roots of 7. So again, putting that 3 in the V as you work through that. Now, one thing I want to mention right now is that some of you were scribblers. So let's just say you got to this point and you looked at that and said, oh, that's 36 cubed roots of 7, and you did this. Oh, you can't do that. Then I can't read what your step was. Your test is communicating to me what you know. You've just taken away any evidence that I have that you know that that was 9 times 4. We don't do that in math. What we do is we use a strike. So we would back up and say, no scribbling, but I can do this. I can still see what math you were doing underneath the strike. So that's what we would take care of there. This was just demonstration purposes. This was our answer right here for the other one. Next up. It was disappointing to see how many people forgot the difference of 2 cubes gets factored the way that it does. This was our u minus v, and then our u squared and our v squared, because again, if you multiply this back together, you have to get something cubed in the front and the back. And then because this has subtraction in it, this first set of parentheses, to get rid of a middle term, that is going to have to be a positive. Now, we look at this and say, well, what's the cubed root of 125x cubed? What did you cube to get that? And that's 5x. And what did you cube to get 8? And that's 2. And you've just found u and v. So you put it into the formula carefully, because here you have to square 5x, and that's 25x squared, plus 10x, plus 4. Now, we talked about this in the video as well, that quadratic that we have sitting there. It's possible that that might still be factorable. It's unlikely 95% of the time. Once you get it factored to this point, you're done. But it certainly didn't hurt. Some of you did b squared minus 4ac, and you saw that 10 squared minus 4 times 25 times 4 was going to come out to be negative. And remember, in order to be factorable, this has to come out to be a perfect square. It definitely was not a perfect square if it's negative. So that means you're done. That's as far as you can go. So basically, if you knew the formula, that question was done. All right, 18. Factor completely or state that the polynomial is prime. So for this one, I noticed that it has 4 terms. And so I started thinking, well, I might have to trick my brain to see this. I'm going to do factoring by grouping. And in the first 2, I noticed there's a y in both of them that I can factor out. And in the back 2, there is a 2. Now, you get to this point, and you start thinking, wait a second, 36 minus x squared. If that were backwards, if that said x squared minus 36, then this would work. So, and some of you noticed that right off the bat. We reverse it. And then we see, oh yeah, x squared minus 36 was there the whole time. It was a factor. I just needed to trick my brain. And if I multiply by y minus 2, I'll have it. But this one is not quite done. And that's because x squared minus 36 is a difference of two squares. So x plus 6 and x minus 6. And then that one is completely factored. Number 19. This one is about domain. So what you have to do is notice the domain will have to be restricted because this is a square root. And we have to take square roots of 0 and positive numbers only. Otherwise, it comes out imaginary. So that means 2x minus 5 is going to have to be greater than or equal to 0. I add 5 to both sides. And one of the things that I'm demonstrating as I go through this video with you is the least amount of steps that I should see from anyone. The very least. And that's what you've seen me demonstrate all the way through the notes. Unless, of course, you haven't been watching and listening to the notes. So we took it like that. If you wanted to put it in interval notation, that would have been even better. But like I said, we took it either way, whether or not you had it as an inequality or you wrote that with interval notation. Number 20. Got a lot of work to do for number 20, but basically the steps are what's going to be incredibly important on this one. So the first thing that you do is factor. You don't flip anything to start with. You do your factoring. And that was the undoing of a few people because you factored incorrectly. And I'm not going to bother talking you through the factoring because you're going to look at it and you're going to know exactly what you did wrong. But there it is. So now I can see what my denominators are, and I can come over here and list those restrictions on the domain. X can't be 1, x can't be negative 3, x can't be 1/2, x can't be negative 3. Oh, I already have that one up there, so I don't need to list that one again. But now I flip it, and I'm going to see some changes to my domain. So I have 2x plus 7 times the quantity x minus 3 over x minus 1 times the quantity x plus 3 times, and you only flip the one that you are dividing by. But when you flip it, you have now created two new restrictions in the domain, because now these are factors. So now we'll have x can't be negative 1/2, and we could just change this one to plus and minus. And we have a positive 3, so we could do a plus and minus on our 3 there as well. And then you do your canceling. Only after you have everything all written out and you can make it all out perfectly. So let's see, we've got an x minus 3 and an x plus 3. But the rest of them, we don't have any perfect matches. So that would mean I have 2x plus 7 times the quantity 2x minus 1 over the quantity x minus 1 times the quantity 2x plus 1. I don't have any new denominators to worry about the domain. And I leave it this way. And the reason I leave it this way is because that shows that I knew to check and see if anything else would cancel out. We don't multiply it back together because we might do that wrong, and we don't want to miss a point for something that was not a step, that wasn't essential. So only essential. Now, number 21. This particular problem, it looked like a lot of you were falling back to the old method. And as I talked about on the video, we have to use the new method. You guys are going to go to calculus next year. So the new method is to find the LCD. And in this case, our denominators are 1 and x minus 2 and x plus 2. So our LCD would be the quantity x minus 2 times the quantity x plus 2. Now, there are 3 terms up here. Terms are separated in this case by division and by addition. So every term needs the x minus 2 and the x plus 2. And we're going to see some good things happen. not right away. Our 3 in the front is going to need both of those. Nothing canceled. But x minus 2 cancels from the back of the other portion of our numerator. And then in our denominator, the x plus 2 cancels out, like so. Now here's what we don't want to do. We do not want to multiply that denominator together. We have to see, is there anything that's going to work out great in our numerator that might be able to factor and cancel with that. So our focus is on the numerator. Now, 3 times the quantity x minus 2 times the quantity x plus 2 is easier to do if you just go ahead and FOIL, or you remember, oh, that's a sum and difference pattern there. And then for the back 2, we would have x squared plus 3x plus 2, too many parentheses, over 3x times the quantity x minus 2. So continuing on and distributing the 3, we'd have 3x squared minus 12 plus x squared plus 3x plus 2 all over 3x times the quantity x minus 2. Combine like terms, and we have 4x squared. What do we have? Plus 3x minus 10 all over 3x times x minus 2. And last but not least, I have to show that I knew that 4x squared plus 3x minus 10 was factorable. So this one takes a little bit of time to find, but it's the quantity x plus 2 times the quantity 4x minus 5, and that is all divided by 3x times the quantity x minus 2. Now, that shows that I knew 4x squared plus 3x minus 10 was factorable, but nothing cancels out. So my final answer would be and we did not ask you to give us any information about the domain restrictions on this one. So that was the correct way, the new method way of using the LCD to get number 21. Number 22, this one says rewrite the expression without absolute value symbols. So what you want to do is think, well, 6 minus pi, that's going to be 6 minus 3 point blah-bitty-hoo. But that's negative, and this is going to make it positive. So just using 6 and pi, how could I get it to give me the exact same value as that positive number? Well, that's not going to do it. So that would give me a negative. Six minus pi would do it. I don't need the absolute value bars. So that's what we would get. Number 23. Find the midpoint of the line segment with the given endpoints. Negative 5, 12, and 14, 3. So midpoint you find by getting the average of the two. So negative 5 plus 14 is 9 divided by 2. And we should write that down. So 9 halves and 15 halves. Needs to be an ordered pair. You're going to lose a quarter of a point if you don't put parentheses around there, because that means you didn't understand what you were finding. What you're finding is a point. And we leave that. The fractions are perfect. We don't want to give decimals. 24, the standard form equation for a circle. You had to remember this formula or derive it using the distance formula. However you were going to do that, it doesn't matter as long as you can get there. So I have an h and a k, and I have an r value. So this will be x plus 3, the quantity squared, plus y plus 8, because minus a negative is a positive, and then the square root of 37 squared. But I can't leave that either, because I know that the square root of 37 squared, those are inverses of each other. So x plus 3 squared plus the quantity y plus 8 squared equals 37. And that's what the standard form for an equation for a circle would look like. All right, new code word, succeed. S-U-C-C-E-E-D. Succeed. Or maybe it's just one C. Anyway, succeed. 25. Verifying algebraically that the given coordinates are that of an isosceles triangle. So these already have the nice labeling of A, B, and C on there. What we have to do is find the distance AB, the distance BC, and the distance AC, and make sure that two of those are going to be the same thing. And again, you have to show those steps. So we have to remember the formula, which is the difference between the two x coordinates, 2 minus a negative 2 squared, plus the difference between the two y coordinates, negative 1 minus 3 squared. Well, 2 minus a negative 2 is 4 squared, plus negative 1 minus 3 is a negative 4 squared. So that's going to be 16 and 16 for a grand total of 32. If you wanted to, you could have that be broken apart, and that's 16 and 2, so 4 square roots of 2. But the square root of 32 would be a place that you can stop, since we just want to see are either of these other two the same thing. And then from BC, square root of negative 5 minus 2 squared, plus negative 4 minus a negative 1 squared. That's the square root of negative 7 squared, plus negative 3 squared. We've got minus a negative in there, so negative 4 plus 1. I'm missing a parenthesis there too. And then that's going to be 49 and 9, which is the square root of 58. That's the square root of 58. So no perfect squares that are going to work for us on that one. AC, negative 5 minus a negative 2 squared, and negative 4 minus 3 squared. Negative 5 minus a negative 2 is negative 5 plus 2, so that's negative 3 squared, and negative 4 minus 3 is a negative 7 squared, and of course we're going to get the square root of 58 again. Now, I have not yet verified that that's isosceles, because nowhere have I put down what I needed to see for this to be isosceles. BC equals AC. Therefore, the triangle is isosceles. That's what an isosceles triangle has. Two sides that are the same length. So that's it. You don't use the Pythagorean theorem. You don't do anything else fancy. You just say, hey, two of these side lengths were the same. Done. 26. Solve the equation. If you make a negative mistake early on in this, you're pretty much toast, and some of you went too fast. So distribute the negative. Combine like terms on the left-hand side. Add 25 to both sides, again showing you the minimum amount of steps that I need to see from everybody on this test. You have to communicate through your test the information that you know. I cannot make any assumptions about what you do know and what you don't know. These steps are what tell me that you know exactly what you're doing. Number 27, this is another one where some of you were using old methods, which leads me to think you didn't watch the video, because when we solve these equations, we're going to find the LCD, and we are going to multiply every one of these terms by that LCD, and in this case it would be 10. So each of these three terms gets multiplied by 10. What you have to be careful about in this one is that this is subtraction. So some of you possibly got burned here because you didn't remember to change that to adding a negative, and you have to distribute that negative. So if we multiply all of these by 10 here, we'll reduce and get 5 times the quantity x plus 9 Here we'll get a 2, and 23 times 2 is 46. Back here, reduce, and we'll have 2 times negative x plus 3, so that will be a negative 2x plus 6. And then go ahead and distribute. And all I did was drop the parentheses there and make plus a negative subtraction. And we need to combine some like terms. And then we go ahead and move the x's over. So let's add 2x to both sides. As usual, I'm writing too big. Again, showing the minimum requirement of steps that you would need to go through this. And at this point, I think I let some people get away with doing the 2 steps in one to put that piece in there. But again, you have to show all of those things, and you have to use the new methods that you've been taught in pre-calculus. Now, number 28. This one caused people a lot of trouble because of the fractions. So here's what you can do to take care of that. Distribute the 1/3. Distribute the 7. Now, before you do anything else, if you don't like working with fractions, here's what you do. You take a peek at it and you say, oh, if I multiplied all of these terms by the LCD, the numbers might be bigger, but I won't have to deal with fractions. So we can multiply everything, every single term, by 3. And that will give us, because these will cancel, x minus 7. 3's here won't cancel out. We'll get minus 9x less than or equal to 42 plus 21x. So now no more fractions. And you can combine some like terms. And then we can add 8x to both sides. Subtract 42 from both sides. And divide both sides by 29. And that's a positive 29, so we don't need to do any flipping. And we'll get x is greater than negative 49/29. And that could be totally reversed in order to get exactly the same answer, but as we would read it off, x is greater than or equal to negative 49/29. Now, I had a little note here about a problem where for some reason people were doing some really goofy math and they were telling me that 19 divided by 8 is 2. Yeah, that is not true. So 19 divided by 8 is not 2 because 8 times 2 is not 19. You just have to slow down for things like that. You're going too fast. That's what's happening here. So you have your code words, and that's the first thing you need to take care of is make sure that you have those code words for me. You have to show me that you've gone through all of this. Let me back up. Go through this list one more time. Then you have to go ahead and go back in your note packet and highlight each of these problems. We had something very, very similar to it in your notes. So highlight those. Redo that review assignment, start to finish. Redo it. Throw out whatever you had before. You need to redo it if you want to do well. And then get a hold of me. And I'll take a look at all the things that you've done so far. And we'll get that retake scheduled for you. So these are the things you need to do, not as punishment, but to help you be successful. So let's give it a little better try. Let's, I think a lot of what's going on is because of the fact that we have this situation going on with COVID. But we need to do the best we can do. And one of those things anyway that's going to help us is to focus on something other than that. And math is a great little retreat for your brain.